Okay, so in this video, I'm going to go over more than just the derivatives of trig inverse functions. It's kind of a comprehensive list of what we learned so far. Let me just see if I can hide that. All right. So we still ask ourselves the same questions, is it a quotient? Is it a product? Is it a function within a function, or is it a basic rule? So we could see in this first one that we do not have a quotient, but we do have a product, and I'm really not going to use algebra, even though I'm just timesing something by a monomial here. I'm going to do a product rule. So let me just make sure I got the right color there. All right. So in this first one, this is the first function, and this is the second. So it's going to be f prime will be the first function, which is x squared plus 1, and the derivative of cosine is negative sine of 3x times 3, plus the second function, which is cosine of 3x, times the derivative of the first, which is 2x. And number two, the derivative of sine inverse. So g prime at t is going to be 1 over the square root of 1 minus the inside stuff squared times, of course, always by the derivative of the inside. And the derivative of 1/4 t is the same thing as t over 4. Its derivative is just 1/4. But we do have to clean this one up by finding a common denominator. So I'm going to make this a 16 over a 16, and then by properties of radicals, I can split up the numerator and the denominator. And that becomes root 16 minus t squared over root 16. And you cannot distribute that square root over the minus sign. So when I do the multiplicative inverse of this bottom fraction, the square root of 16 is 4. So this whole thing will become 4 over the square root of 16 minus t squared times 1/4. And there's my final answer, 1 over that square root. In number 3, do I have a quotient? No. Do I have a product? Yes. Would I do a product rule or algebra first? It's going to be algebra first. So f at t is going to be equal to 3t. Got to add those exponents, which would be 7/2 minus 4t, and 1 plus 1/2 is 3/2 plus t to the 1/2. Now I can take its derivative by dropping down the power, making it 21/2 t to the 5/2 minus 2t to the 1/2 plus 1/2 t to the negative 1/2. And number 4, do I have a quotient? And the answer is yes, but I would not do algebra first. There's really no algebra there to do. I'm just going to do a quotient rule. It's a pretty classic quotient rule. So it's the bottom times root of the top minus the top times root of the bottom, all over my bottom squared here. And I distribute on top to get me 3x squared plus 3. You can throw this in front if you want, minus 6x squared plus 4x. And then I'll combine like terms for that to give me negative 3x squared plus 4x plus 3 all over my bottom squared. And this one here, I don't have a quotient, I don't have a product, but I have a function within a function within a function. So the outside function is actually this cube. So I'm going to rewrite this as the sine of 2x squared to the third power. This is the outside, this is the inside. The derivative of the outside is a power function. So I'm going to drop down the power, repeat the inside, decrease the power by 1, and times it by the derivative of the inside, which would be cosine of 2x squared times 4x. Over here in number 6, it's tangent inverse. So f prime of x, the derivative of the outside is 1 over 1 plus the inside squared, which would be 4x squared over 9, times the derivative of that inside, which is just 2/3. And once again in these, you've got to get a common denominator. So I'm going to make that 1 a 9 over a 9. Maybe I should rewrite that in a separate step. So this would become 9 over 9 plus 4x squared over 9. And that consolidates to 4x squared plus 9 over 9. But because that's in the denominator, I got to invert and multiply. So this whole thing will become 9 over 4x squared plus 9 times 2/3. And then this will become a 1 and that a 3. And I'll get 6 over 4x squared plus 9. And number 7, it's not a quotient, not a product. It's sine inverse, the same thing as arc sine. So its derivative is 1 over the square root of 1 minus the inside stuff squared times the derivative of the inside, which is by now 1/2 x to the negative 1/2, or 1 over 2 root of x. And these will just cancel out because they're inverses of each other. And there is my answer. And number 8 is that classic product rule that we have to clean up. So f prime of x is the first function. Hopefully I have enough room here. I'm going to start a little back more so I have enough room. So f prime of x is the first times the derivative of the second plus the second times the derivative of the first. Okay, so don't forget that it's never a derivative times a derivative. I do have to clean this one up. So 3 times 3 is 9. I'm just going to like squeeze the first half together as well as the second half together. And this is where factoring is the name of the game. I'm going to factor out that 2x plus 3 to the first and a 3x plus 1 squared. And then return, I'm going to have a 9 times 2x plus 3 plus a 4 times 3x plus 1. You don't have to rewrite everything all over again. It's just going to give you 18x plus 27 plus 12x plus 4, which combines to give me 30x plus 31. And number 9 is a classic of a function within a function within a function. So the derivative of the outside is secant squared. Repeat the inside, and now times it by the derivative of the inside. But the derivative of sine is cosine. Repeat the inside and times it by the derivative of the inside. And number 10 is kind of subtle, but it's a product rule. So y prime would be the first times the derivative of the second, which is negative cosecant squared of x cubed times 3x squared plus cotangent of x cubed times 6x squared. And number 11, we have to be able to find the equation of a tangent line. So tangent line triggers a slope, which is the derivative, and the derivative of cosine is negative sine of 3x times 3. And I need to evaluate that at pi over 2. So it's negative 3 sine. When I insert the pi over 2 in for the x, I get 3 pi over 2. And that's a quadrantal angle, and that puts us down here, where the y coordinate's negative 1. And that minus 3 times that negative 1 is going to give me 3 as my slope. But I also need a point, and the x value is pi over 2, and the y value is found by subbing that in. And the cosine of 3 pi over 2 is 0. So that ordered pair is pi over 2, comma 0. So now you didn't find the line yet, so it's going to be y minus 0 over x minus pi over 2 equals my slope of 3. I'm going to cross multiply. Don't really have to distribute. And there's my equation. Obviously, the 0 doesn't mean anything. And number 12, again, a tangent line triggers a slope and a point. The derivative of secant is just secant tangent. And I got to evaluate that at pi over 3. So it's good trig here. So when I substitute that in, I get this to become secant of 2 pi over 3 times the tangent of 2 pi over 3 times that 2 from the outside. We can't skirt over here the tedious stuff. So here, this is pi over 3, root 3, negative 1 and 2, because when I graph that angle, 2/3 pi puts me in the second quadrant. And my reference angle is that pi over 3. So that's root 3 across from the pi over 3, negative 1 and 2. The secant of that angle is r over x, so that's 2 over negative 1. The tangent of that is root 3 over negative 1. I guess that looks like a positive 2 root of 3. Now for this y value, when I substitute that in, it's the secant of 2 pi over 3, which I already have. So I don't have to redo anything. So it's just going to be negative 2 because it's 2 over negative 1. So my ordered pair is pi over 3, comma, negative 2, right? So I got my slope, I got my point. What's the setup going to be? Y minus a negative 2 over x minus pi over 3 equals my slope. I'm going to do something a little different here. That becomes y plus 2 equals 2 root of 3 times x minus pi over 3. And I don't really need to distribute that because it's just going to be a hot mess altogether. Distributing is not going to really simplify things. But I do have to carry over the minus 2. And number 13, now we got to evaluate the limit now that we know our derivatives. So I got to recognize this is the definition of derivative. It's the limit as h going to 0. And I need the function, and I need the a value. The function is the sine function. It's right here, evaluated at pi. So the derivative of sine is cosine of x. And now I'll sub in the pi, and the cosine of pi, pi puts me over here, and the x-coordinate there is negative 1. So now we're responsible for putting down the final answer. In part B, my function is cosine of x, and my a value is pi over 3. The derivative of cosine is minus sine of x, but I'm going to evaluate that at pi over 3. So I draw pi over 3 in the first quadrant. Crossing pi over 3 is root 3, 1 and 2. The sine value is the y over the r, so it's minus root 3 over 2. In part C, it's the limit as x approaches a, not h approaching 0. So I can immediately see that my a value is 3. And in this definition of derivative form, it's the function that goes first minus f at a. So my function's right here. It is x squared minus 2x. So the derivative of that by a power rule is 2x minus 2. I'll replace the x with 3. Kind of doing it in my head here. 6 minus 2 is now 4. And finally in D, it's the definition of derivative with h going to 0. I need two things, a function and an a value. So my function is in this part tangent of 2x, because in this form, it's f at x plus h minus f of x. So after the minus sign tells me an indication of what my function is. And I'll also look at it from here too. And my a value is just x. So the derivative of tangent 2x, derivative of tangent is secant squared. Repeat the inside and times it by 2. There is no x value, so it stays in terms of x. In number 14, these are these problems that we have to find the derivative, but there's no values of x, so we can't evaluate anything. So in number 14, it's a function within a function. So you take the derivative of the outside, so symbolically, the derivative of f is f prime. You repeat the inside, but then you have to times it by the derivative of the inside. And the derivative of that inside is g prime, derivative of the outside, repeat the inside, and times it by the derivative of the inside. The chain of derivatives, right? Here, I would do a quotient rule, no algebra. So it's the bottom function, f of x, times the root of the top, which is 2x, minus the top, times the root of the bottom, all over the bottom squared. And number 14, the derivative of the outside is g prime. You repeat the inside, times the derivative of the inside, which is f prime of sine of 2x, times the derivative of the inside again, which is cosine of 2x times 2. So this is, the derivative of the outside is g prime. Repeat the inside, but then you have to times it by the derivative of the inside. The derivative of the inside is f prime. Repeat the inside, and the derivative of the inside is cosine of 2x times 2. Here I'm going to take the power to the outside. So y prime. So now it's a power rule. It's a power rule because the outside function is a power. This derivative is not just cosine squared or cosine. The outside function's a power rule. So I'm going to drop down the 2. That's how I differentiate a power rule. Decrease the power by 1 is 2. And I did repeat my inside here. But now I have to times it by the derivative of the inside. So the derivative of sine is cosine. Repeat the inside. And then the derivative of the inside is parentheses 1 minus g prime of x squared times 2x. So because the derivative of sine is positive cosine, I repeat the inside, but the derivative of this inside, the derivative of x is 1, the derivative of g is g prime, repeat the inside times by the derivative of the inside. And now for the summary of our derivative rules. Product rule. Y prime is the first times the derivative of the second plus the second times the derivative of the first. Y prime is the bottom times the derivative of the first minus the first, the times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Function within a function, the derivative of the outside, actually, as we can just do this, is f prime, repeat the inside, and times it by the derivative of the inside. This is our power rule. We'll drop down the power and multiply, repeat the x, and decrease the power by 1. The derivative of sine u is cosine of u times u prime. Can't forget the u prime. Derivative of cosine u is negative sine u times u prime. The derivative of tangent u is secant squared u times u prime. The derivative of secant is secant u, tangent u times u prime. The derivative of cosecant u is negative cosecant u, cotangent u times u prime. And the derivative of cotangent u is negative cosecant squared u times u prime. The derivative of sine inverse is 1 over the square root of 1 minus u squared times u prime. The derivative of tangent inverse is 1 over 1 plus u squared times u prime. The derivative of e to the u is e to the u times u prime. The derivative of ln of u is 1 over u times u prime. And the derivative of an exponential function whose base is not u is the function itself, which is a to the u, times the ln of its base, times the derivative of the exponent. And we'll leave these go right here. Just know that we can expand this to be ln of a plus ln of b, and know that we can expand this to be ln of a minus ln of b. And then we're going to talk about implicit. The implicit differentiation is that if we have a y squared, its derivative would be 2y dy dx. If we had a 3y squared, its derivative would be 6y dy dx. Every time we differentiate a y, we're putting dy dx. We just have to obey the rule that we have. So if we had y cubed, its derivative would be 3y squared dy dx. And that's a great summary of all the trig derivatives.